Hello everyone, my name is Eric. Today I want to talk about the LeetCode challenge on June 15, which is searching a binary search tree. The problem is, given a value, we have to find where is the value in the binary search tree. And I want to talk about the definition of the binary search tree first. Given a node in the binary search tree, the left subtree of the given node will be smaller than our current node, and the right subtree of the current node will be bigger than the current node. So if we want to find a value, we just check whether it is equal, whether it is smaller or bigger than the current node. If it is smaller, the answer must be in the left subtree. If the value is bigger than the current node, then the answer must be in the right subtree. If it is equal, it means the current node is the answer. And for example, if we want to search 2 in this subtree, what we have to do is to check with the 4. Because 2 is smaller than 4, we know that 2 must be in the left subtree of 4. So we will go to the left side. And then we found that 2 is equal to 2. So this subtree, 213, is the answer. And if we want to find the value 5 in this subtree, we will first to check with the 4, compare with the 4, and we know that 5 is bigger than 4, so we will go to the right side, and then we will compare with the 7, and 5 is smaller than 7, so we will go to the left side. However, we can find nothing in the left side, so we will return null, which means we cannot find 5 in this subtree. So to implement this, we can write a while loop, and I use the root to means the current node, and we will start with the root, and then if we find the answer, we just return it. And if the value is bigger than the current node value, we will go to the right side of the current node. If the current node is smaller than the current value, then we will go to the left side of the current node. After the while loop, if we still cannot find any value is equal to the VAL, it means we cannot find the value in the binary search tree. Then we will return none. And I want to talk about the time complexity of this problem. The time complexity is equal to the height of the binary search tree. Because what we have to search is the path, the maximum path will be the head of the tree. So the worst case can be big O n if the tree is really skewed. For example, for the tree 1, 2, 3, 4, 5, and 5 is the root, then with the head will be 5. It is the worst condition. In this case, the complexity can be big O n. However, if the tree is very balanced, it can be log n. And for this problem, we not only can use the iterative method just like this, we can also write this in a recursive version. But if we use a recursive version, also the code may be simpler. We have to use memory in the code stack. So iterative method is more efficient in this method. Thank you for listening my video.